Hello, I'm going to talk you through the working memory model now, which is the second of the memory models that you need to know. So you've already got your multi-store model, and now you've got your working memory model. This is a really commonly asked about thing in the exams, so you really need to make sure that you've got your head around it, much like the multi-store model that we looked at before. So why the working memory model came in was that the researchers that developed the model thought that short-term memory was more complicated than just having one unitary store. So we looked at that as a criticism of short-term memory, that was just one unitary store. So a working memory model tries to elaborate on this to say that memory is not just one store, it does different things. So they describe working memory and short-term memory as the bit of memory that you're using when you're working on something. So it's the bit of memory that you are using for a specific task at a specific time. The working memory model, like the multi-store model, can be described in diagrammatic form. So you can sketch a diagram, you can draw out the working memory model, or you can describe the working memory model in an AO1 question. Again, it's completely up to you as to how you want to remember it. There's a few different ways that you will see a diagram of the working memory model. I have the two most common here. So you've got this one, and then you've got the second one here. If we go back, both have the same sections, the same features that you need to know. You've got something called the phonological loop, you've got the central executive, you've got the visuospatial sketchpad, you've got the episodic buffer. So all of those features are in both diagrams. It doesn't matter which diagram you learn. Look, they're all the same. As if you want to learn it in diagrammatic form, that is fine. If you want to sketch it out, again, that is fine. If you have a look in your textbook and on Caboodle as well, you might see another version of the diagram. So you've got these different bits. You've got the central executive, you've got the visuospatial sketchpad, the episodic buffer, and the phonological loop. Now, just to say, when you are writing down these different sections, you can use a shortened version name. You can kind of use initials, an acronym, to remember the different sections. So CE for central executive, VSS for visual spatial sketchpad, EB for episodic buffer, and so on. And I have used those later on in this presentation, but to be safe in an exam, I would always write the full name. So I would always write out the full central executive, episodic buffer, phonological loop, and so on. Okay, so you've got these four main components. You've got the central executive, which is the bit in charge. It's like a control tower. It directs attention to particular tasks. So it works out which part of your memory you want to use and directs the correct part of memory to that. You've got the phonological loop, which is to do with sound. That can be subdivided into the phonological store and the articulatory process, which is also known as the inner ear and the inner voice. So that's the phonological loop. So that's sound stuff. The visuospatial sketchpad is visual stuff you can see and where stuff is. And then you've got the episodic buffer, which is a more general store that's used less. The three more important bits are the central executive, the phonological loop, and the visuospatial sketchpad. The central executive decides what you're doing. It processes information from all the senses and directs it to the different systems. So these are sometimes referred to as the slave system. So the phonological loop would be a slave system. The central executive can only do one strand of information at a time and will selectively attend to different things at different times. It has a limited capacity and it cannot store information. It's just as a kind of a route to get stuff done. Each of these different stores, each of these different sections, there is research support, usually by Baddeley, to demonstrate the existence of each of these bits of the model. There's a study here by Baddeley where participants generated digit strings on keyboards, and Baddeley found that the central executive was being competed for in terms of the tasks. So you've got the study here, and it's also in your textbook if you want to read up a bit more on it. It's just research to support the existence of the central executive. There's a video here where Alan Baddeley, the guy that does the research, describes the central executive and describes the research on the origins of the central executive, and I would recommend that you watch it. The next section is the phonological loop, so that's the sound stuff. It has a very limited capacity, and it's got your two subsystems. It's got the inner voice and the inner ear, so the articulatory process and the phonological store. But it's all to do with sound. And again, you've got some research, by Baddeley that proves the existence of the phonological store. The next section is the visual spatial sketchpad, which is the inner eye, where things are, where they are located. Now, this can be subdivided into the visual cache and the inner scribe. You don't necessarily need those subdivisions, but they are there if you want to add a bit more information. And again, some research, it's Gathercole and Baddeley, demonstrating that the visual spatial sketchpad exists, and it's to do with the visual tracing tasks, so where people are looking at a dot of light. Okay, the episodic buffer was added later on, and it's more of a kind of a general storage capacity, like an additional storage in the working memory model. It keeps time, it can help send information to long-term memory, but this was a section that was added later on to the model. There's a video here about the visual spatial sketchpad and other aspects of the working memory model. Again, it's worth a look just to kind of make sure you've got your head around what the different stores are and what they do. Some research by Baddeley and Hitch. You will need to know research to support the model, some kind of research. You might be asked an exam question on describing research. So there's some research here. Take some time to have a read at it. It's in your textbook. Make sure that you understand what they did in the study and what they found, because that's the two things you'd be asked about in an exam question. What did they do? What did they find? Now we've got some AO3, some evaluation points for the working memory model. So the two on this slide are kind of positive points, if you like to look at them in that way. The first one talks about the fact that there is case study evidence to support the working memory model. The example you've got there is KF. So the man that had the accident and suffered from brain damage that we mentioned before. So you could use that to support the working memory model. The second point there is about the fact there's this thing called dual task performance, the fact that you could do a visual task and you can do an auditory task at the same time, suggesting that they're in different stores. It's the idea behind when you're driving, it's safe to drive and sing along to whatever music you're listening to at the same time, because they use different stores in the working memory model. But if you were to drive and then go to read something on your phone, that's why it's so dangerous, because both of those tasks compete for the same area of the working memory model and you're unable to concentrate on both at once. So the 2 points in here are positives in terms of supporting the model. This point here is a negative about the working memory model, saying that there's a lack of clarity about the central executive, about what it does, and about kind of the impact it has within the model. These 2 points are again positive. You've got some research on the word length effect that supports the idea of the working memory model, because you've only got so much space in your articulatory process. And then you've got some research support from brain scans. So it's some biological evidence that different parts of your brain are being used when you carry out different tasks. Okay. Hope you enjoyed that. Thank you.